Let me share my screen. Cool. Yeah. So today's session mainly will focus on two things called authorization and authentication. Uh, we'll look at the tools that are used behind these, how to actually implement them, and obviously we'll build a project also as we go along. Just a second. Good. If you have any doubts, just drop it in the chat box or feel free to unmute and look in. So today we'll take at these main topics: authentication versus authorization, the core differences, why we actually need to implement them, and then we'll take the different ways of implementing them. One way is like cookies, other way is called tokens, and the third is obviously combining these two, making your application even more secure. And then we'll try to implement the same auth system inside our student management system. Okay? And at the end of it, I'll just share a small task. So you guys can work on it as well. So that you get online practice over this. So in the previous session, we learned about EJS. We had the views folder that holds all our embedded JavaScript files, right? So that in the server time, it converts the code in your server into HTML and then gives it to your user. So that's what EJS is all about. Even Pub, even Jinga, all these are similar libraries you can use. Okay. I just kept a few add-ons just so we can get started. I've used the code, pretty much all the code from the fifth session with some small changes. I've added a new / path to render the index page. Basically, this page will have an option to create a form, and that form will post request to this request here to create a new student. And once the new student is created, it will redirect to the individual student page. And then I've also changed these two pages instead of showing /API/students, and so showing the individual students data in JSON format. I'm directly sending it as a I'm directly sending that as a HTML page to the user. Okay, so right now it's not connected to my server because my database, because I haven't started it. Let me boot it up. I mean, booting it up, that's kind of good. Cool. I mean, let's see. Let's restart the server. Wait for it. It should be, yep. Okay, so it's running right now. It's going on. 9,000. Good. So basically, the index page just returns this stuff over here, a navbar and a form to create a new student. If we take a look at the code, you can see there's a views folder index which contains my form. And if you see there's something new here called include statement, partials, header, and then bottom also does the same thing, include partials, footer. If you work with React, you can very much correlate this to some components. Components or these partials are nothing but pieces of code that are reusable in more than one place. So in my form page, I will have the same header and footer throughout my application, right? There won't be much difference anywhere where I use it, even including the viewing the individual student. The header is going to remain the same. The navbar is going to be same in all the pages. So why do I have to put the effort to write the same navbar code everywhere while I can just write it in one place like this and reuse the same code everywhere else? So this is some cool thing, right? In a real world application, if you're using EJS, you'll probably end up with around 15 to 20 pages that you'll be rendering. And there will be a common navbar for at least 5 to 10 pages, right? If you have to make one change in one place, you'll have to do it in all the files. So instead of doing that, you just create a partial, You can name it anything. You can name it components also. But when you're working with EJS, the general convention is to name it partials. And in that, you keep your common code. In this case, header is my common code. So this will remain common for all my pages. And I can just use it by making use of the include statement provided by EJS. Okay. So creating a new student just takes in the name, register number, register 52, and department is itself. Okay, I'll create, and it will redirect me to this page. Right, it works absolutely fine. I have created 2 more students before 5-1, same thing, and then 1 more for like this for another friend. So it works. So this navbar is common. The create student takes me back to the index page. Get all students basically brings the students list and renders it out here. So to do that, I've used this something called EGS for each statement. So I'm passing the students array, the list of students from the backend to the EGS file. And then it's basically it's an array of objects, right? So for each of the students, render them with their name, register number, department, and obviously link each student to their own individual page. So if I click on this student, it will take me to that student's page with the register number. I can go back to that page and it will have all the students over here. I've also just kept a check like if there are no students yet, then directly show no students added, create one to get started. These are checks that you can do in front-end frameworks also. Usually it's a lot shorter than this and a lot more clean to read. But yeah, this is one way to get started before React or anything else. This is how it actually used to be done. And this is pretty cool stuff. So just take a look. For now, I haven't implemented 2 things. One was the delete and one was the edit the name. So that is actually your task for today's session, being able to create pages, EJS pages, where you can, go to a particular student. You'll have an option to edit their name. It will update their name. And the second one within this, maybe you can create like a delete button here, or within that student page, you can create a delete button so that deletes the student from the database. Okay, so these were the 2 things I additionally created. For the styling, I'm just using Tailwind and I'm not actually compiling. I'm just using the place CDN so I can directly use the Tailwind classes. Okay, so just if you want, you can add styling. That's totally up to you. It's not mandatory. Just I'm looking for the functionality that you guys can implement. Nothing much else. Okay. Cool. So this was the early updates from the code that I've done. Let's actually get started. Okay. So we have 2 different terms, right? Authentication, authorization. When you start learning, they more or less seem the same word. Yeah. Okay, so you might end up using them interchangeably, but they do have a significant difference in how they are actually associated when it comes to securing an application. So authentication, as you can see, basically means verifying a user's identity, and authorization means verifying if the user has access to resources and actions related to the application. This might be a bit confusing, so I just took a very simple example. Imagine our college, right? SRMIST as a web app, and we have 2 different entities, the students and the faculties, right? As students and as faculties, we have access to the resources that the college provides, library, labs, canteens, all this. You're able to have, I mean, canteens, you can exclude, anybody can come take that. But mainly the library and the labs, right? Both students and faculties are able to access it because they both have the authentication required to access them. They are both verified entities of the college, of the web app. Okay. I mean, here you can see. So they both have access to this. But then when it comes to things like updating a student's marks or updating a student's attendance, you're not allowed to do that as a student, right? Only your teachers and faculties can do that. So in this case, only your faculties are authorized to do that. They have access to do these certain actions. So That's why they can do it and you can't. This is the very simple example I could find that I guess you can relate to as well. So authentication means giving access to the whole or common features of the web app, whereas authorization means selectively giving access to certain resources or certain actions to specific users. In this case, faculties can update marks and attendance, whereas students cannot. But both faculties and students have access to the SRM resources, buildings, and labs, all that. Okay. So I hope the terms are clear. This is what you need to understand in general. We can go in depth later, but this is more than enough for now. Right? Good. So the first method of authenticating a user is basically cookies. Web cookies, you will call them. Ignore my very poor drawing of attempted cookies over here. Okay. So cookies are basically small chunks of data that both your server and your browser manage together. So you could call it like a stateful data because it's constantly being tracked by both entities, your browser and your server. And it does not have to be necessarily for authentication alone. Basically, your Amazon cart is that right? It basically uses something called a cart ID that can later be used by the date server to fetch your cart, then can also be used by analytics and for marketing purposes. Whenever you go to a website, it asks, right, allow access to cookies. And then it gives you an options of like preferences, functional cookies, marketing cookies, analytics cookies. Functional ones are always put mandatory, whereas others are optional, right? So they help track your action in the web app so that they let the owner of the web application know how you're interacting with their web app and also certain other features, mainly speaking, authentication. Okay. So we can actually try it out, head over to this package, cookie parser. Basically, cookie parser allows us to yeah, allows us to create cookies, get a list of cookies, and read the cookies so that we can see how the user is actually behaving. We'll do that with our current application also. Okay. So come to your app and just open a new terminal and put in my cookie password. Password that is installed. So this package that we just installed, it's basically a middleware. Like how let's go to the server.js. We had the express.json, which gave an access to request.body, right? The body object was created for the application JSON request. And even this one to access the form request in the body itself. Similarly, to access cookies that come in your request, you have something called upload use cookie passes. You need to import the package. Okay. After you require the package, just uh, place it like that. Okay, so don't worry about these options and all. They are not required at the moment. Just know that after you place this middleware, the cookie passer middleware, you get access to a special object called the request.cookies. So all your cookies that are exchanged between your browser and your server can be accessed to this object over here. All right. So I don't want to tie it up. Let's actually get it working. So I'll just come all the way to the bottom. I'll just put a draft called read cookies. Okay, so after simple get request forward slash cookies request and for now just response or status. I just want to see what the cookies actually are. I'll just put console.log request.cookies. See, it shows me I have access to an object called request.cookies. I'll open up Postman. Just feel free to stop me in the middle if you guys are having any doubts. Have the student mind. Let it load. Add a request. Okay. It's a get request. Okay. So we just go these. Okay. And we'll send it. Cool. Right now, it's you can see object and prototype. Basically, it's an empty object. Cool. Yeah. Okay. So how do I actually get the cookie? Assuming your browser already has some, we can just we don't we don't have any cookies over here yet. That's specifically because your server manages how your cookies are created, and your browser is just responsible of handling uh, saving the cookies and sending the cookies back to the server. So imagine you have your browser over here and your server. Okay. I mean, this is one way to do it. So what happens is I create my cookies over here, these cookies. Okay. It's always created in your server. Okay. Just keep that in mind. I create my cookies here. Imagine my user is logged in, their password is all correct. And then I create a cookie. I send it to my browser. Browser, what it does is it stores that cookie. Okay, hey, the server told this is the user, and this is the cookie associated with that user, store it. So now when I'm going to create another request, another example, let's take Instagram itself. You log in, you get a cookie from the server, and then you want to create a post. So before you create a post, it needs to know that, hey, this is the user, he's allowed to create a post. So what happens is the same cookie is sent back to the server. Okay, it's sent back to the server. It checks, hey, okay, this cookie is having this user ID. It was created this. Is it still valid? Okay, it's still valid. Let the user create the post. So this is the general workflow you'd expect. So anything related to creating cookies is done on the server, and anything related to managing cookies, delete expired cookies, yeah, expired cookies, all this creating and reading basically, reading are done by the server. Okay, so I hope this is clear. Let's just try to do that. So right now we have no cookies, right? As I told you, because there is nothing created yet. So let's use our server to create a cookie. So app.get slash cookies slash create. Let's give it a get request request response. Then request dot cookies. I guess it was let's take the documentation. So this does keep happening from time to time. I do forget how to actually use it. Yep, got it. Yeah, so response.cookie takes in the name of the cookie, what is the actual content of the cookie, and then various other parameters like how long should the cookie be valid for, and whether or not it can be accessed only by the server or both by the client and the server. Okay, so let's just write it out. So response.cookie over here. You have the name of the cookie, so let's just, for learning purposes, name it my cookie value, let it be, put your name. Okay. And then here you have various options. You can see max age, basically how long does the cookie last for? It takes it in milliseconds. Signed cookies, whether will the cookie have a special way of encoding, whether the actual data sent is encoded or not. We don't have to worry about that now. And the path is basically through which paths is the cookie actually valid for. So right now we don't have to look at, but general example, think of this. In the /login path, maybe I can be looking for the authentication cookie, whereas for the normal / path, which just shows the information about the website, I don't need it then. So I can set which paths to actually look the cookie for. And there's one more thing called HTTP true. So that basically sets whether the cookie can be read only by my server, or it can be read both by my server and my browser. So here I'll just put HTTP true, and the max age maybe, I guess, let's see. Let's keep 3,000 for a minute. 3,600, maybe like that, 6,000. You know, that is good for 60,000. 60,000 milliseconds convert to seconds, 60 seconds, which is a minute. Okay, so this is done. And then I'll just send I'll just send a response back to my server telling like, hey, the cookie was created. So just to clarify, let's go to Postman. I don't have any cookies right now. I'll create another one. Okay. You know, let's actually follow convention, but I'm not feeling comfortable keeping this thing. Let's cover to post. David, for Postman. Converted to a posting post and cookies / create. I'll send a request. Okay, it's not request, it's response, because I'm going to respond with a new cookie to the server. Honest mistake. But yeah, so request.cookies basically means it gives the list of cookies that come from the browser, which is basically created from the server to the browser. And response.cookie basically means you're creating a cookie in the server and then setting it in your browser. Okay, so you're responding, meaning you're going to send the cookie. Request means you're getting the cookie. All right. Let's do this. Yep, cookie created, and let's head over to cookies. And yeah, you can see my cookie with the value Kunal Percentage 20 is basically the Unicode character for a space. Domain is basically which domain it can, since you're working locally, it's showing localhost, and path is / and it expires. Let's see, 13, I guess in this. Hopefully that is a minute from now. I mean, I can't read 24, sorry. Too much out of mind for that. Okay, so let's try to send this. Now we try to read our cookies. So we get the cookie back again because it's already part of the browser. So we can see it's there. I'll go to my server and you can see the cookie is actually there. Pretty cool, right? So I can access my cookie in my server also now, which I basically created in my server, sent to browser. And then from my browser, I sent it back to the server. So it's a to and fro motion with the cookies. So that's why it's called stateful. It's managed between both your server and your browser at the same time. Okay. Okay. We'll get to the actual authentication part in a minute. We'll do that with both the tokens and the cookies towards the end. And I missed out a very important topic. Um, yeah, the importance of why we are actually learning cookies and why we're learning tokens, right? So right now, the student management API that we built, basically anyone can come and create a student, delete a student, and change the name. There is no restriction of who can actually do it, right? So my data is not protected at all. Anybody can access it. Anybody can misuse my data, and that is why we actually need to set up authentication. You putting authentication allows a user with the right credentials and the right roles to able to access the application in such a way that only they have access to critical operations like creating a new student, editing the name, or deleting a student. While reading a student's details and all can be public, usually not, but in this case, imagine it can be public, but the sensitive operations like creating and deleting should not be. There should be under control of, example, say the faculty or the ITKM department as well. Well, they have the access to do it, not not anyone in the public in general. Okay, so this is the main reason why we need authentication to keep our data secure, to keep our backend secure from maybe cyber attacks. Uh, Maybe you can look into DDoS, man in the middle, XCRF attacks. All these are some of the things that you learn when it comes to web security. I can take that later on, but yeah, so keeping your data secure and your application secure through these various methods allows you to at least reduce those attacks, those malicious intents as to some extent. All right. There is nothing more to cookies. Only these two main things. You can look into signed and secure cookies later, but they're not important at the moment. So next thing we have something called JSON web tokens or tokens in general. Yeah. So over here, you can uh, set data just like a cookie, but here you have access to various algorithms in which you can encode and decode your data. So these algorithms are basically called cryptography methods. Uh, Maybe you must seen RS-264, EC something. There are many algorithms that this JWT supports. And they obviously come with base 64 formatting, so it's readable to uh, humanize as well, but it's tough to decode because while you might know the algorithm, it comes with a layer of security called signed encryption. So basically, you have a secret key, uh, just like a house key that only you know, that only you have, and using that only you can open the lock, right? Same way over here, imagine the lock that is publicly accessible. Anybody can see it. That is your algorithm. Anybody can see it. But to actually open the lock, you need the key. So that key is your signed token. That token cannot be opened. That token cannot be decoded without that signed key. Okay, so let me just make a very open representation. So this is your log. You have your key. So your log is your algorithm to encode, decode data. And then you have your key. Key is the sign or secret to access or hide the data. Just take it as an analogy. You use the key to lock the home. You use the secret to lock your data. You use the algorithm to make sure the data uh, is encoded. You use the lock to make sure your house is protected. Okay. Then yeah. So in this case, it is stateless. It is not managed by your server, neither your browser. We can create cookies as per our own will, and how we manage authentication with it is up to us. Okay. And for doing this, we basically have a package called JSON Web Token. But before that, we'll actually see how it works. Go to jwt.io. I mean, it's pronounced as jot or something. You can put it as jwt jot, up to you. Okay. So here we have a debugger over here. Let's actually see. You have algorithms. You can choose anything out of here. I'll just go with the default one, and you can put in your data. So you have something called your payload. Yeah, so payload is your actual data that you're going to protect, and it's usually expects as a string or an object. I'll just put it as a string over here. I'll just put my name. Okay, and then basically it expects a signature. Signature is basically your secret or your key that we discussed, right? It can either be this or it can be a basic one also. Doesn't have to be. So I'll just put here my secret sort of thing. It will give reshape, but just ignore that one. So once you put you can see the output is already on the side. Okay. So your JWT consists of three parts: your payload, your headers, and your encryption algorithm. So the first one usually involves what your actually data is, but you can see this is my actual data compared to what it's actually been encoded into. It's not readable, right? If you were someone who are not a programmer, you'll not be able to figure out what this actually is. Okay. Okay, I'm sorry. It's mentioned over here. The colors are that. This is my actual data. The header, the payload, and the signature or the algorithm used, right? So it's all in one single string format over here. And I can use this to increase the level of security between how my data is sent from one location to another or how it's stored. Okay, so these are the main use of tokens. You can create it using something called the JSON Web Token library. Let's go to that. This is the link. Okay, I'll install it. Good. Okay. For now, I'll just not create request to it. I'll just do it directly in the server since it's being console here. Okay. AWT JSON web token. Switch off to say I'll just create something called my secret equal to my secret sort of thing. And let's just see close console.log JWT. So to create a token, you basically take the secret, take the data, and then you lock the data using the secret, right? And in the lock terms, it's just putting a key and locking it. But in token terms, basically sign a secret. So you just use sign method. And then over here, you pass in two things. The payload, it can be a string object or a buffer. You can see the highlight object. I'll just put my name. Okay. And over here, it asks the key. So I'll just put my, I guess the spelling is wrong, but let's ignore that. And over here, I can pass in other options also. It asks, I can pass in the algorithm when it expires, maybe some additional IDs I can put and all that. Let's ignore this for now. Okay. And let's see if this works. Good. It's here, right? I will just copy this. I'll go to data.io. And I'll just put the invalid signature, right? Makes it my underscore secret. Cool. So now it's showing the exact data. I mean, we just put in the same thing. That's why it's looking different. But now, how do I verify it, right? I can't keep going to the website and putting it. So to verify it, we have another method. Okay, so I just put line was this and put console. Just for viewing purposes, jwt.verify. And over here, it takes in the signed token, as token basically that we just created, and it takes in the key back. Okay, so what this does is it verifies whether your token is valid or not. It basically returns the decoded data that you can see from the token. Yeah, and if it does not match, it will probably throw an error. For now, it matches, right? So let's just save it. Cool. You can see the data is actually being consoled. What if I just change one small thing? I put this small I as capital I save it. It throws an error. Right? This is exactly how we expect it to work. Invalid token. Because the one data that we actually got is not valid, right? Cool. Yeah. So this was the general thing you might want to work with. So let's actually see how we can combine your cookies and your tokens to create a authentication system, mainly to, like uh, over here to hide our creating students. Well, if you're authenticated, then well, you'll be able to do it in that case. So for that, first we actually need a login page. There's this you create a route for that. So app dot login student. I mean login, suppose say faculty. And let's just keep a fixed credentials for now. So const credentials, we'll keep it as their username. Just put your name and a password. 1, 2, 3, something like that. Not the most secure, but it's something. Okay. So you log in faculty. I mean, not login faculty, more like login user or someone who has access. It's not usually we don't store it here. We fetch the username from database, check if the user exists. If the user exists, then check the password. But that's a whole other process. We're just interested in getting to see if the user is valid or not. Okay. So app.code/API/login request response request handler. And what we'll do is we'll take the username and the password from the request.body. Make sure there's a try catch around it. I just copy paste the same things from everywhere else. And over here we can just compare if user dot I mean if username is equal to credentials dot username and password is equal to credentials dot password. If this is satisfied, then basically response dot status 200 uh, with a message and login successful. If this does not match, we just go new error, invalid credentials. Okay, this I'm throwing an error because it will be caught by a cache block automatically. It will console the error and render the error page. Okay. So this is done. Now, along with this, for every other request, I told you we need a cookie, right? So let's just create a cookie, response.cookie. And we'll be setting the token. So this will be like odd token sort of thing. And that token will create it from JWT. Token is equal to JWT dot sign. Here we'll pass in maybe the username itself. And the secret basically we'll just create one, is it? Credentials secret. Hello. The secret. Okay. And we'll just sign it with the same secret. Good. And this token, we'll send it back to the as a response. And we keep HTTP 1ES2 along with max age of say 1 day. So 24 hours into each hour has 60 minutes. Each minute has 60 seconds into 1,000. I guess this is right. Okay. Good. Let's actually test it out. Let's go to create a post request. So let's log in user. This is post request and this is dash API slash login. And in the body, we have to send in the username and password. So if these are not there by default, it should give me the error page, right? I'll just send the request. And review this. We didn't actually send the message, but okay, let's just add the data. Jason, username, password. Just put the wrong password for now. Send the request. It's taking the invalid credential and message. We have the error here. Cool, we got it. Yeah, preview it. It's showing error message invalid credentials. So it's actually working now. And let's put the right credentials 1, 2, 3. Send it. Login successful, and you can see there's a cookie also created. Auth token with the JWT. You can see it's in the same format, and it expires tomorrow same time, right? Because we put it to expire in 1 day. Cool, right? So it actually works. So now, how do I actually make sure that well, if I'm logged in, I can create a student of sorts and all that. So I'll just go to the create student. it's not just / number, and it's a simple get request. Okay, so I have these three fields, right? Right now it's still open. Even though I authenticated a user, there is no way to check whether the user is actually logged in or not. So since I told you, you can check it by getting access to the request.cookies. Let's just do something called creating a middleware. So I'll just put function or which takes in the request response next. Okay. Try catch block over here. Okay. I'll just put the same things, these two. In my auth middleware. And in the over here, what I'll do is I'll extract the auth token from the request.cookies because we saw it was an object, right? So I should be able to restructure this. So if auth token if auth token is that, then what you do is const decoded data is equal to dwt.verify. Take in the auth token and the secret, right? So credentials dot secret. And if decoded dot username is there, then go to the next, okay, meaning allowed. In every other case, else throw new error, not allowed. And similarly, if the auth token is also not there, just throw new error. Okay, so how can I use this? Pretty simple. Just copy the auth and go to my, suppose say to create a new student and just place it in the middle of the request handler and the route. That's what middleware will actually, right? So I'll save this. Let's try it in the browser where I haven't actually logged in. So I'll come back here. I'll enter a name. Let's keep this completely easy. I'll create the request. I'm saying, hey, not allowed. Works, right? Because I haven't logged in here. Let's go to Postman. I'll go to 54 department EC. I'll click on create. Okay, I need to log in through my actual app also. But yeah, basically, what you can do is try to create a login portal within your application, and you'll be able to try it out whether or not you can create a new student or not. Right? I mean, just try it out. You'll get an idea of how it actually works in the front end. So what I actually want you guys to do is try to create a login flow. Yeah, I've written it out as well. Back here. Yeah. So I guess there's one more thing. At the login page, login.eds, make sure the login works. And after login successful, bring them back to the index page. Okay. Additionally, on top of that, try to create a delete.egs, edit.egs, and obviously implement the auth middleware. It's very basic. You can reuse the same code if you want. Try to write it once by yourself, but make sure these routes specifically, creating new student, deleting a student, and editing a student's name. All these three routes should be authenticated. So only the user who logged in has access to create that specific user. All right. Cool. Yeah, that was it, guys. If you have any doubts, let me know. Obviously, I will push the code, share the recording. If you're part of the TD organization, you'll already have access to the code that we're working on. And yeah, that was it. I'll just push it now. Just let me know if you guys have any doubts. That was it for today, guys. Yeah, thanks for coming. So let me know. I have received a task. If you're not given yet, I'll do give it and review the other tasks soon by this week.